Alrighty, this is day 2 for area of a plane region. For the region, let me get the highlighter. For the region of figure 5.8c, which I suppose is this region right there, by the graphs, blah. Yeah, that is this graph. This is I can tell this is a parabola because there's a square involved. It's a sideways parabola because it's y squared. And because it's negative y squared, it's facing left. And this one, which is a line, which seems to be this one right there. Write an integral for the area and evaluate numerically. Evaluate the integral exactly by the fundamental theorem and compare your answers. Alrighty, so let's talk about this. First thing to talk about is the fact that we have a function that is going from left to right instead of up and down, from down to up. And the reason why that's okay is because we have dy. If this was dx, we would have a huge issue. But because it's dy, we're doing fine. For dx, we usually do top minus bottom. For dy, we do pretty much the same thing. Top in this case would be right, and bottom would be left. Because the right side is where we have all the positive, the left side is where we have all the negatives. Well, for the dx, we said top minus bottom, because the top is where all the positives were, and bottom was where all the negatives were. So the first thing we're going to do is we need to find out what a and b is. Oops. Let's erase that. So in order to do that, we have to find where they intersect. As you can see in the graph, there's going to be an intersectioning happening. Okay, now it's not writing at all. There's an intersection happening right there. There's an intersection happening right there. Also, one thing I should probably highlight is the whole concept of integral, when you go dy instead of dx. For dx, we did slices like this. And then the bottom part, we called that dx. So this little slice, that's way too big. Let's erase this. Alright. So this bottom part, we just called that dx. But in this case, we're dealing with dy. So it's not going to be a slice this way, it's going to be different. It's going to be exactly what it shows you. It's going to be a slice like this now. The slice is right here. By the way, when I was doing slices, I should have done it like that. You know what I mean? Because this is pretty much what we're trying to find, these kind of slices. But because it's dy, the slice is going to be this way. Because dy represents a change in y. So this little thing right here, that's called dy. Alrighty, so there's this difference when you think of integral. We first thought of them as Pringle chips that happen this way. And we just have an infinite number of those. In Atom, this time, it's going to be like this instead. We are going to have a lot of slices like this. And then we have an infinite number of them, we add them together, and boom, we have our answer, which is going to be an area. Alrighty, so we need to find out where they intersect. So you can do a math for it. You can use, I'm assuming they use the calculator or something. But essentially what you need to do is kind of find your y's. So what you would have to do is take the x plus y equaling -1. Solve that for x. So we have -1 minus y. And then plug that into here and pretty much find out what y is going to be. So during this process, they got y equaling 4 and y equaling -1. So, which makes sense. When you do this, you expect to have let me just go ahead and do it real quick. We would get -1 minus y equaling 3 plus 2y minus y squared. That is a quadratic. You expect to have a y equals and then a y equals. And they got 4 and -1. I feel guilty not doing this. There's always this pressure. Okay, I'm just going to go ahead and do it. So 0 equals, add 1 to both sides, that's a 4. Add 1 on both sides, that's a 3y. And then you're going to have minus y squared. We switch it up a little bit, turn into y squared minus 3y minus 4. And two numbers that multiply to give you -4 and -3 when you add them would be -4 and +1. So you have y that and y that. Okay, so you would end up getting y equaling 4 from this one and y equaling 1 from this one. Alright, now that that's squared away, you get your a's, your a and b, plug it in, and then you do the integral. By the way, don't forget right and left. You start with the right function first, which is the parabola. The left function is the line. Here we have the parabola minus the line. Sorry, the parabola minus the line. I'm not sure if I'd even, I just talked and didn't even outline. The right function is the parabola. The left function is the line, because we're going from right to left. And as you can see, parabola and line. So that's how they set it up. And you have to go from -1 to 4. Alright, so let's do this integral. Okay, that's just straightforward integration. This turns into this if you just organize things and add like terms, right? Yeah, that's 3y, yeah. Then you take the integral, you plug in the 4 and then the -1, subtract them, don't forget that, and you end up getting your values. So, boom. That's pretty much what they ended up with after doing some math. All right, let's do another one. Alrighty, let's go over this problem. Let f of x equal 2x squared minus 6x plus 4 and g of x equaling this. Let R be the region bounded by the graph f and g as shown in the figure above. Find the area of the region. Okay. Well, we have to first find out what they look like. So you want to analyze this function, and we're going to be dealing with x's, so it's not like the other problem. So our slice is going to be vertically now. They're not going to be horizontal. So it's going to be straightforward. So we're going to start with the top function, and then we have a bottom function. Let me use a different color. The top function seems to be the... okay, that's definitely the cosine, because cosine usually starts at 0 and then moves downwards. And then the bottom function is going to be the parabola, which is this guy. So it's going to be this minus this. So that's kind of how they set it up. Cosine minus the parabola. You need to find out where they intersect, so you make that equal this and do some math, just like we did before, because they didn't really tell you where they intersect. They did give you this graph, so you can kind of tell it's going to be from 0 to 2. So it starts from 0, you go to 2, you do the integral. And, oh, by the way, there's a minus. Don't forget the minus. So it's going to be top minus the bottom. So cosine minus the parabola. And then separate the integration, which makes sense. If you're wondering how they got from here to here, they did a u substitution. And what they ended up doing is they changed the limits. They changed the limits right here. That's according to what u is. They let u equal pi over 4x. So you plug in 2 into pi over 4x. You get 2 times pi over 4, which is pi over 2. And then when you plug in 0, nothing changes, so it's just 0. You do this integration. So this integration gives you this integration gives you this. And then you simply do the math, and you end up getting an answer, which is an exact answer. When you have a pi and you answer, that's called an exact answer. Alrighty, so we are finished. By the way, for no calculators, that's kind of what you expected. You're supposed to have exact answers. We're done. So that's it for the video. I tried to keep it short because yes, the last video was very long. It has a do now that was pretty botched. It was pretty bad. I didn't even analyze the problem before doing it. So do apologize for the previous video. This video is finished. See you guys tomorrow.